Okay, students, let me write the given data from the question. So, in the question, what is the thread profile given? Thread profile. What is the thread profile? ISO trapezoidal. So, ISO trapezoidal thread. So this thread has been given. So what is the angle, thread angle for such type of threads? 2 theta is equal to 30 degrees. So this we know. Okay. Now what else? Outer diameter of a screw is given. Outer diameter of a screw D0 is equal to 30 mm, and pitch is also given as 6 mm. And what is the load given? Load. So F is equal to 1.5 into 10 raised to 3 newtons. Now here the collar diameters, that is inner diameter of a collar and outer diameter, that is also given. So DCI, inside diameter of a collar 30 mm, and outside diameter of a collar, which is given as 50 mm. Okay, and the problem also states that screw rotates at 40 rpm. Screw rotates at 40 rpm. Okay, and coefficient of friction between screw and nut small f equal to 0.14, that is given, and collar friction also given, small fc, that is equal to 0.09. And here very important, in the problem they are telling you it is a single start. Single start means lead is equal to pitch. So lead L is equal to pitch. So pitch is given as 6 mm. Why I am writing the question? They are telling it is a single start. Okay. Now find the power required to drive the screw. So what is the power? So that they are asking. Okay. So power, this you are supposed to find. Okay. Now this is the given data in the question. There are some data which you have to find depending on these data. So what is that? Now you have got outside diameter of a screw. So inside diameter, that is DI, inner diameter of a screw, right? Or it is also called minor diameter. Minor diameter or inside diameter of a screw. So what is the relation we have seen in the previous lecture? Outer diameter minus pitch. So 30 minus 6 is equal to 24 mm. So this is inside diameter of a screw, outer diameter of a screw. Fine. Now what is the mean diameter of a screw? D0 plus DI divided by 2. So 30 plus 24 divided by 2. So how much is that? 27 mm. Correct? So this is related to screw. Okay. Now collar inside diameter and outer diameter are also given. So what is the mean diameter of a collar? So that we will find. That is, so it is, this one dm is mean diameter screw. Now DCM or DC, DC is nothing but mean diameter of a collar. So what is that? Outer diameter of a collar plus inner diameter of a collar divided by 2. 30 plus 50 divided by 2. So how much is that? 40 mm. Okay, 30 plus 50 divided by 2. So now we have got all the data. So let us come to what they are asking now. Power required. Power required. So what is the expression? Power is equal to, you are already aware of this, 2 pi nt divided by 60 into 1000. Now n is given, RPM of a screw which is rotating at 40 RPM. If you find torque, then you can easily find the power now, right? So torque is equal to, so collar friction also given. So this expression we have derived, right? Fdm by 2 to the bracket tan of phi plus alpha plus Fc dc by dm. Equation 9.19, page number 1111. So this equation we have derived. Torque required to raise the load or lift the load, right? Including collar friction means this term will come, FCDC by dm. How this will come, so that also we have seen. Okay. So if you find this torque value, the power can be easily found. So one by one we'll try to find now. So let us first find this phi. Okay. So it is isotrapezoidal thread. So coefficient of friction, coefficient of friction is F by cos theta is equal to what? Is equal to tan of phi. So this is also known to you. So F is given as small f 0.14 divided by cos 15 is equal to tan of phi. Correct? Therefore phi is equal to tan inverse of this part. So calculate that one, tan inverse of that. So you will be getting 8.24 degrees. So you can check in your calculators. So what is this? This is phi. That is friction angle. Friction angle. Okay. So this part also we have found, right? F is known, dm mean diameter is known. What is this alpha? So that we'll find now. Okay. So let me quickly, this data you take it. So let me make some space over here so that we can do further calculation. Okay. So what is tan alpha? Lead divided by pi dm, right? So tan alpha is equal to, what is say L is 6 divided by pi mean diameter is how much? 27 into 27. So alpha is equal to tan inverse of this part. So that comes to be tan inverse of this part. So that will come 4.04 degrees. Okay. So FC is given in the data question only. Mean diameter of a collar DC, that also we know, mean diameter of a screw. So we have got all the values. We will substitute now so we'll be getting a torque value. So here torque is equal to, what is the force? 1.5 into 10 raised to 3 divided by 2. Mean diameter is 27. Tan of 8.24 plus 4.04 plus FC 0, mean this one, friction for collar, so that is also given in the question. DC, that is 40 divided by mean diameter of a screw. So if you solve this, so torque will be getting at 7107.8 Newton mm, because of dimensions you are substituting in mm. Okay, so if you convert this into Newton meters, it is 7.107. So let me write it over here. So it is 7.107 Newton meters. Okay, if you substitute in meters, so this is the value. So we have got the torque now. So power easily we can calculate. So that, let me write here. So power P is equal to, power required P is equal to, so 2 pi, RPM of a screw is 40 RPM given. So 7107.8. So that is the torque what we have got. So that value divided by 60 into 1000. Okay. So how much we will be getting? 29.77 watt. So this is the answer. Okay. So power required to drive the screw is 29.77 watts. Okay, students? Yes. Okay, now we'll write the given data according to the question. So what is the load? F. So 20 into 10 raised to 3 newtons. 20 into 10 raised to 3 newtons. Okay. So what is the outer diameter of a screw given? 30 mm. 30 mm. And what is the pitch given? Pitch is equal to 6 mm. So that is the data given related to screw. And what is the outer diameter of a collar given? Yes, 100 mm. Okay. And inside diameter of a collar is also given, I think. Yes. So inside diameter of a collar, that is 70 mm. Okay. And coefficient of friction F is equal to 0.12 for screw and for collar 0.14. Fine. What else it is given? So square thread profile is square thread, which is mentioned in the question. Square thread. Okay. So again it is mentioned in the question, it is a single start. It is a single start means L is equal to P, which is 6 mm, because it is single start. So what data, anything else is given? So the lead screw is propelled at a speed of 5 meter per minute. So V is equal to 5 meter per minute or 5 into 10 raised to 3 mm per minute. So this V will be used to find N. So once you find N, then you will get a power. So that is why indirectly they have given this one. Okay. So we'll see how to convert this into RPM. Okay. So anything else is given? Okay, that's it. So this is the given data in the question. So now for nominal diameter of a screw, for nominal diameter, that is D0 is given now 30 mm. For screw it is whatever we are writing now, it is for screw. Now what is the inside diameter? So that, for that you are supposed to use data handbook. So let me show you. So you see here page number 108 for square threads, outer, that is normal diameter 30 mm, and for pitch 6 mm. So what is the minor diameter? That is inside diameter. It is for 30, it is 24. Okay. So di is equal to 24. So di is equal to 24 mm. Correct. So this I have written from page number 118, table 9.9. Fine. So this is the data related to screw. D0 is known, Di is known. Now in this only, mean diameter of screw dm is equal to d0 plus di by 2. So dm is 30 plus 24 divided by 2. So again it is 27 mm. Okay. Now for collar, mean diameter of collar DC is equal to DC outer and inner collar diameter upon 2. So this directly given. So 172. So 85 mm. Fine. So once you got this data, so very easy. Now what is the first thing they are asking? Previously what we calculated, no, power required. So power required So P is equal to 2 pi nt by 16 to 1000. Okay. So there, what is torque here? Torque is equal to, so that expression is same, the previous expression, F dm by 2 tan of phi plus alpha plus Fc dc by dm. So equation number from the handbook 9.19, page number 1111, so it remains same. So here first we'll find friction angle. So it is a square thread. So for square thread, coefficient of friction F is equal to directly tan phi. Other than square thread, then F by cos theta. Square thread means F equal to tan phi. So phi is equal to tan inverse of F. So 0.12 is there. So friction angle is 6.84 degrees. Next is tan alpha is equal to lead upon pi dm. So L is known, dm is known. Tan inverse of that term, if you find, then alpha comes to be 4.04 degrees. Fine. So I think you have got all the data now. So if you substitute this value and all these given data, DC also you have found mean diameter of a collar, mean diameter of a screw. Substitute in this torque equation. So torque you will be getting as 170896.06 Newton mm. So this is the torque which you have got. Now N directly it is not given. So speed equal to, but cutting speed is given, no? Cutting speed, if you divide this cutting speed by lead, the distance traveled by this one nut for one revolution, no? So that is the, if you divide that speed by lead, you will be getting RPM, right? So just observe this velocity, meter per minute or mm per minute you have taken. So N is equal to 5 into 10 raised to 3 divided by lead is 6. So it comes to be how much RPM? 853.34 RPM. This relation you can write only if you know meaning of what is lead. What is the meaning of lead or lead? So if you know that, then only for one revolution how much distance it is covering. So only based on that concept you are writing this. Okay. So once you have got this N RPM, so very easy to get the power now. Substitute the torque value which you got here, N value, in this expression power. So power you will be getting from this expression. So if you substitute, you will be getting 14913.43 watts. So this is the power which you have got, 14913.43 watts. Okay. So this is regarding first part. Now in the second part they're asking you height of the nut. Okay, so height of the nut, so that I'll tell you. So second part, height of the nut. So height of the nut, I'll tell you from the data book. So again, if you want to go to page number 1111, page number 1111. So this is the page number 1111. You see here number of thread necessary in the nut. So equations have been given now. So 9.26 height of the nut. So that first I will write. Okay. So height of the nut, H is equal to N into P. 9.26, page number 1111. But what is N? N for, so bearing pressure is given in the question. So this equation you have to refer now. N is number of thread necessary in the nut. For bearing it is this expression 9.24. So let me copy that one. But N is equal to 2 times F so whether it is a bearing pressure or shearing pressure. So let me just so yes, bearing pressure is given. So it is 4 times F divided by bearing pressure pi d naught square minus di square, equation 9.24. Okay, so this is given. Okay, now if you substitute in this, F is known to you, so N is equal to 4 times 20 into 10 raised to 3 load. Bearing pressure is given in the question, 70 into pi. Outer diameter is 30 square minus 27 square. So it comes to be 8.75. But the threads will not be in fraction, no, threads has to be complete. So we will take it as almost equal to 9. So 9 threads will be there. So number of threads are 9. Okay. So N is equal to 9. But what is the height of the nut? Therefore, height of the nut is equal to 9 into pitch is 6. So how much? Yes, 54 mm. So height of the nut is 54 mm. So this is it regarding the height of the nut. So last part they are asking, what they are asking? So let me write over here. Efficiency of drive. So efficiency, what we have derived, so tan alpha upon tan of phi plus alpha, right? But if you remember, this we have derived efficiency without considering a collar friction, remember. Now I told you, if when I am going to consider a collar friction, so this term you have to add FCDC by dm. This entire term related to collar friction. Without collar friction, if you are finding efficiency, don't include this. only this you have in data handbook, tan alpha upon tan phi plus alpha. So let me show you that one. So here, efficiency for square threads. So this is without considering collar friction. This we have in data handbook and we have derived this. But if you are including a collar friction, then efficiency, this extra term, so that is not there in data handbook, so that you have to remember. If you are including a collar friction, so this term you have to add, FCDC by dm. So you don't need to remember this. So here you see this term is there, no? Equation which you have used, torque required to raise the load for collar friction, including collar friction. So this term only you can just add FCDC by dm. Okay. So this part you remember, which is not there in data handbook. So now if you substitute the values there, efficiency, so tan of 4.04 divided by tan of 4, what is the friction angle? 6.84 plus 4.04 plus collar friction is 0.14, and how much is DC? 85 divided by 27 is mean diameter. Correct? So this entire term is all multiplied by 100. So efficiency will be 11.1%. So this is the efficiency of a power screw. So this is the answer. Fine. Efficiency of a power screw. Clear? Yes, thank you students.